So what I'm going to focus on today is start out by just talking a little bit about the compressor, the CO2 compressors from BITZER, just so we are all on the same page with the terminology I'm using and the fact that the transcritical compressors are the only ones that are going to have this very step or CMRC associated with them. We don't have unloading, mechanical unloading for the subcritical compressors. We kind of do, but it's not very, it's in field trial, I guess you could say, or if it's really something that an OEM and an end user wants, we can do it. It's just not very common. Very step, by the way, is just the BITZER marketing name for mechanical unloading. We have a very speed, which is an inverter attached to an integrated compressor with an integrated inverter. We have a very pack, which is an external BITZER branded VFD, and then the very speed. So very step is the mechanical unloading. So it's just a marketing name, it's capacity regulation, that's all it is. Most of the training will focus on the best software. If we have time, we could talk about, if we have time, we can talk about the last one of the best BITZER software. The best software is a tool to connect to all our IQ devices, our intelligent devices. The BITZER software is a selection program for BITZER compressors. I forgot to mention this, but please ask questions during the presentation, even if it's not 100% related to what I'm talking about. If you have a question about BITZER, CO2, non-CO2, feel free to ask. I don't want to just sit up here and talk if it's not something that's relevant to you guys, or if you have a question. I'm around a little bit afterwards. I do have to catch a flight, but I'll leave some contact information for tech support as well, so you can use that if you have any questions. So BITZER has two, if you sat through some other presentations, subcritical and transcritical is basically where you're operating within the vapor dome or outside of the vapor dome. So subcritical compressors for CO2 look a lot like all our HFC compressors. So the one way you can identify, this pointer doesn't work very well with the screen. One way you can identify a CO2 compressor is there's a pressure relief valve. So for our subcritical SL series, the pressure relief valve is on the suction service valve. When I say SL series, when you look at the nameplate, you'll see something like this. These two letters here are the series, and so when we will say SL series or ME series or TE series, that's what we're referring to. Number of cylinders, displacement, it's a letter. You can look into the software to see what the actual displacement is. SL is just a series nomenclature. Nominal horsepower, and then the type of motor. And the 2NU is the most common motor. It's dual voltage. Set up the jumper bars per the drawing. You do 208 or 460, depending on what you need. So the SL series, we have up to a 4-cylinder, 30 horsepower. That's the biggest SL series. And the pressures are shown here on the low side, 432, on the high side, 769. So this is important for designing systems, obviously. You know the pressure limits of the components. But if you happen to be doing some sort of replacement of a compressor or retrofit or something like that, and you want to check leak, if it leaks by pressurizing it, you can't exceed 432. Because if you exceed 432, the discharge side will hold, but the suction side won't. So the low pressure side. So some people look at 769, and usually this is at the OEM level when they're doing the quality inspection before they put it in. They'll want to check it for leaks. We do this at our factory, and they pressurize it to 770 pounds, and they say it leaks. And yes, 99% of the compressor is at low side. Only 1/2 of the cylinder heads are on the high side. So it will leak if you do that. So just kind of keep that in mind. Next series is the ME series. So again, it's subcritical. It's for low temp. The ME series has high standstill pressure. So instead of the 430 and 770, we have 1450 on both the low side and the high side. So what that allows system designers to do is use this compressor and eliminate the backup condensing unit in case of power failure. They can size all their components for a higher bar to make sure that in a power failure that you're not going to lose refrigerant. This is more typical on the industrial side or the cold storage side. Supermarkets, refrigeration don't tend to spend the extra money for this feature. because, again, you have to size all your other components to hold that pressure as well, so it becomes rather more expensive and, may not be of value to them. But the other big benefit of ME compressors is we have two bigger displacements, so we have two 6-cylinder compressors. So again, on larger loads, now you have fewer compressors on the low temp side, and there's obviously a financial advantage to that. So the ME series, like I said with the SL, is just, we refer to it by these two digits. So ME is high standstill pressure, still subcritical, and the SL is subcritical but lower pressures. The other advantage of an ME is we actually offer two motors for the same displacement. So in this case, the displacement is the second digit, the P. So the ME series, wrong way. The ME series would have a motor 2, which is a lower horsepower motor, and a motor 1, which is a higher horsepower motor. So if you're just buying the ME series because you want the higher standstill pressure and don't need to operate in that extended window, then you get motor 1. And it still can operate and still can withstand the pressures. You just can't operate at those higher pressures. So if you need to operate in the upper region there, then you get a motor 2, which would, instead of a 40 horsepower, it'd be a 50 horsepower. Instead of 25, it might be a 30. The displacement and capacity is the same, though, because it doesn't change. It just gives you more of a window to operate in. So that's another advantage of the ME compressors. You can kind of see one of the differences up here. If you look at the bolts on the side here, and can't really tell on the top, but you see how many extra bolts this one has, or more bolts than the SL, because we have to hold that 1450 PSI in there. So you can't tell from the view, but the casting is thicker, and then we have more bolts to hold that pressure in. So if you have a lot of bolts on the compressor, it's going to be either TE, which is transcritical, or an ME. Other difference is there's no pressure relief valve, external pressure relief valve on the ME series, because we have the higher standstill pressure is not necessary. So those are some of the differences and where you use which one. Transcritical echo line, so these are compressors for the high stage or high side of the booster, and these would be the compressors that would use the CMRC for capacity regulation. So the pressures are shown up there, 1450 on the low side and 2300 on the high side, and the nomenclature is very similar. The only thing I added is the last two digits. Those don't show up on the nameplate, but they will for build purposes and ordering purposes. You want to identify how many steps of unloading you want or you need, and then whether the compressor shipped dry or has oil in it. Again, unless you're doing some sort of replacement, this wouldn't be relevant. It probably comes to you with the number of unloaders and oil, but I just want to point that out. The other compressors do not have, the ones I just showed, ME and SL, you don't have any mechanical unloading, so they'll all be zeros. It's 0D or 0K instead of a 1. All right. This has a pressure relief valve as well, but this pressure relief valve is on the discharge side. So it's over here. It's connected to the body of the compressor, not the service valve. So that's another difference. The SL series with the relief valve up here, it's on the service valve. So when you close that service valve, the relief valve is in play. And what it's doing is it's protecting, so say you close the service valves if you didn't pump out all the CO2 or pull out all the CO2. If it gets hot, that CO2 pressure is going to go way up and it's going to go past the 770. And if you don't have a relief valve, something's going to give, right? So that's what that relief valve for. When it's operating and you have the valves open, that relief valve is out of play. It's not a system relief valve. It shouldn't be used for any protection other than making sure when the compressor's not in use and closed off that it's not going to create an issue for you. So, you take it out of your system, you put it in the van, you go to lunch, and it's 100 degrees in Sacramento, it's going to go off if the refrigerant is still in there. So that's what that's for. On the transcritical, it is also a compressor protection. It's on the discharge side. So even if you close off the service valves, it's in play when that system's running, or when the system is, when the compressor's running, or when the compressor's valved off because it's in the body of the compressor. It's on the discharge side. That relief valve, by the way, if it relieves, you'll know it, number one, but it relieves it blows it sideways, so it doesn't blow it out. You can see it's pointing to the right. but the gas won't shoot out the end. It shoots out perpendicular to the compressor. So hopefully, the idea being you're most likely in front of the compressor if you're close by, and this dissipates it to the sides. To my knowledge, I only know 2 in North America that have ever popped off. And again, all your system valves should open before this one does. This is the last one that should open.
What is it release at?
What's that?
What is it release at?
What does it release at? I don't know the exact number, but it has to, I think, within 10 PSI or something of the 2320. So it's pretty close. I mean, it doesn't go much above that. And it has to open up within so much period of time. There's some rules to it. I could look it up, but it's in that 2000. So but you have, typically, most systems aren't even designed for 160 bar. 140 is more typical. So your relief valves on your system should be quite a bit lower. But if something happens, we want to make sure that the compressor is not, the pressure reaches 160, above 160 bar, that compressor has a way to relieve itself and not rely on the system. So the TE series also has an M1 and M2, same logic. M2 is a bigger motor, so it looks like you can run at higher pressure. You can, but not because of the casting, just because the motor has the power to operate there. So if you need this bigger window, then you're going to want to pick the higher of the 2 motor horsepowers. And that's per displacement. So the 4-cylinder 20 horsepower compressor, you don't pick a 6-cylinder 40 horsepower compressor because you want the bigger window. If you pick a 6-cylinder 40 horsepower, you're going to get more capacity and you're going to oversize it. But if there are 2 4-cylinders with the same displacement and they have 2 motors, motor 2 is the smaller of the 2, smaller window. Motor 1, higher horsepower, bigger window. And the reason these charts are different sizes is because I tried to scale it so that they're the same reference. So if you look here, you go up 400 and 1250, you do the same thing over there. So you can see you're kind of in the middle of the window over here. In this one, same conditions, you have much more room on the suction side and the condensing side with that bigger motor. So typically the parallel compressor will be motor 1 if you're doing parallel compression. If you watch some other presentations, they talked about parallel compression because you're trying to, operating up here in the top right corner, use more power, but you get more capacity, so you're more efficient because you're working with smaller pressure ratios versus down in the bottom left corner. So the higher the pressure ratio, the less efficient the compressor is. So for parallel compression, you want to try to get the highest pressure ratio to do the work, and that's where you use a motor 1. One place you could use a motor 1 for a booster system. So we'll get into vari-step now. Like I said before, vari-step is the term for capacity regulation, mechanical capacity regulation for compressors. So we have vari-step for regular compressors, or HFC compressors, excuse me, and then vari-step for CO2. There's some slight differences between the two. They're obviously not interchangeable because we have the higher pressures, but I'll go through some of the differences. And then we'll start talking about the CMRC, which is this device up here, and how that interacts and how you can use it to control the unloaders, and then also how it can be used to do some troubleshooting and gathering of data on the compressor. So capacity regulation, the vari-step works the same and looks very similar to unloaders you're used to with our compressors or other competitors' compressors. There's just going to be a solenoid a stem and a coil on the cylinder head. For CO2, if you want to put unloaders on all the cylinder heads on the compressor, 2 on a 4-cylinder or 3 on a 6-cylinder, you can run it down to 10% nominal capacity using the CMRC, which is that module. If you don't want to use the module, then you are limited to 1 step of unloading for 4 cylinders and 2 step for 6 cylinders. And it's step control, so it's discrete, either 50 or 100. You have to just pick between the two. With the CMRC, we have an algorithm to energize and de-energize coil to try to get to 75% or 80% or 83%. You won't be able to do that with without the CM module. So for CO2, all the experience we've had so far, everybody's just going with the CMRC because it not only does it control unloading, but it does lots of other things, so there's a benefit. And then they don't have to work out their own algorithm to try to get smooth capacity regulation.
So these aren't variable speeds?
These are not variable speeds.
Not, that's what this is for.
Yeah. So up until now, for CO2 compressors, your only choice for capacity regulation was a VFD because there was no mechanical unloading. So with the TE series, we introduced mechanical unloading. Now you have a choice of VFD, but you wouldn't do both. You can't do both. You don't have enough mass flow if you go over the motor if you do both. But you could do both on a rack. Compressor 1 could have a VFD. Compressor 2 could have mechanical unloading, and that way you can get better staging. Or you can do 2 with mechanical unloading, a 4 and a 6 cylinder. Now you have a bunch of steps, but they can be used both on the same rack, but not on the same compressor. All right, so one important thing to know, most importantly, is that the TE series is our latest series for CO2.
What's the lowest capacity you could go on a VFD?
30 hertz, 25 or 30 hertz, depending on a 6, 4, or 2.
You're able to go lower with that module to get more capacity.
Yes. And exactly. So basically 50% on a VFD from 60 to 35 hertz. You can overspeed on a VFD. So in theory, if you go to 70 or 75, it's going to be a little lower than 50%. But this does go lower than the VFD. And I'm not going to pretend that it's, there's the greatest thing since sliced bread. VFDs are more efficient, though, because you're slowing down the motor. Here, you're basically cutting down the mass flow by just eliminating 2 cylinders. So the motor's still working and pushing up and down. You're just cutting down the mass flow. But there's some cost effectiveness, right? In terms of this is less expensive, especially for larger VF motors. You get larger VFDs, and VFDs, in some cases, are more expensive than the compressor. Also, a lot of VFDs, what happens in the field with a VFD? Blow up, or there's an issue on a Friday. What happens? They put it in bypass, come back, then you forget to come back or whatever else. Because VFDs are complicated. I mean, we sell a lot of VFDs as well. There's a lot of parameters, and they can get complicated. And in many cases, the VFD ends up being bypassed at some point, and then the end user loses the benefit of the VFD. This mechanical unloading is very common. People, I think, are more comfortable with it, and it's easier to kind of. So there's benefits to both, and like I said, we do have a lot of stores in Europe, especially, that have both on it. They have a VFD and an unloader, just to really get to fine-tune that suction pressure and keep it nice and stable.
The issue that I had with the VFD would be that it would ramp too low and I'd lose my oil pressure.
Yeah, so that is individual to the compressor. You're going to have lower mass flow going through the compressor, but the oil is going to come back based on the mass flow of the system. So as long as you get oil back to the compressor with mechanical unloading, you won't have that issue necessarily. But if you have a large rack and it's a really cold winter and you're down to one compressor and you're going to load it, you're still going to run into that same issue. You're not going to have enough mass flow through the system to get the oil back. So it doesn't really solve that problem, but it is an option to use in conjunction with VFDs or in place of VFDs. The reason why you can't retrofit it back to the old TC models is because there's some additional machining right here in the cylinder heads that's required for the mechanical unloading that doesn't exist in the TC. So you can retrofit the compressor. You can take a TC out and put a TE in. And let me go back one. When I refer to TC and TE, I'm referring to this letter here, these 2 letters. So last year we finished the redesign of all our CO2 compressors, transcritical, and the nomenclature changed from a TC to a TE. And you can see right here, so Octagon is obsolete now, and the Ecoline is the current version. So that's what I'm referring to. But you can replace the compressor if you have poor control on a rack. You can replace a TC compressor with a TE and add unloaders, and hopefully get a little better control on a rack. Okay, so how does mechanical unloading work for a CO2 compressor, it's basically the same thing, right? So the first line is it cuts off the cylinders. So under each cylinder head, there's 2 pistons. On a 4-cylinder, when you unload it, you're killing the mass flow through those 2 pistons. They move up and down, but there's no compression happening, and that's how you unload our HFC compressors, and that's how this ends up unloading as well. The difference is the design is slightly different because we have to deal with this 1,400, or actually up to 2,000 PSI, 2,300 PSI. So there are some mechanical differences, and the major difference is that the valve plate has a check valve, and that check valve is shown here on number 4. Right? So this is the valve plate, this is the unloader head, and this is the stem and coil, and this is the piston. So this valve plate here, that gap right there is actually a check valve. So what happens is when you energize the coil to unload the compressor. If you don't energize the coil or don't put a coil on the stem, the compressor runs at 100%. When you energize the coil, it lifts up a little pin based on pressure. It lifts up a little pin and allows this gas that's trying to be compressed by the cylinder to kind of bypass and go back to suction. And when that happens, if we don't have this check valve in there, what would happen is that all that high pressure discharge that's on the other side of that check valve is going to rush back into the cylinder head and then recompress, and we don't want to do that because that's super inefficient. So that check valve prevents the high pressure from going back into the cylinder head and getting recompressed. And then what happens on the cylinder, on the suction side, is that piston goes up and down, but it's not working against the high pressure, so there's no pressure, no compression happening. It's just pumping the same pressure around in a bypass loop. Right? And that's why it's not as efficient as a VFD. The VFD, you slow it down, it's still pumping, still doing work, but you're doing it at a slower speed, so a lower power. Your power will go down with a mechanical unloader, it just doesn't go down as much as the capacity goes down, so it becomes less efficient. But it's simple, it's really easy to understand, really easy to parameterize compared to a VFD, and it's very difficult to bypass. I mean, I say difficult. It's less of a reason to bypass. You can just pull the coil off and you've bypassed it, but it's easier to troubleshoot and diagnose. And it's easier to know exactly what's going on, too. We do have a KT document if you really want to read into how it actually works. It's KT 102. This is the revision number, so if there's a 2, it just means it's a newer revision, but KT 102 is the document number, and it goes into more detail of how the mechanical unloading works with the CO2 compressor. So this, by the way, is not a CO2 compressor, but it's the best picture I had with everything connected, so I just want to point that out. So the CMRC comes as an accessory. Again, if you're working on a rack that's already been built, then you don't have to worry too much about this, but it does give you the information on what's included or what can be included with a CMRC. So the first 5 digits have to do with the module and the number of pistons on the compressor. The next one, the 4th digit, oh, my numbering's off up there, sorry. The one that says 4th digit lubrication type is whether it has a positive displacement oil pump, which is included on all our 6 and 8 cylinder compressors, or whether it has a centrifugal disc that does lubrication. So if it has a positive displacement oil pump, there's a switch on there or a transducer to measure that pressure differential. If it has a centrifugal lubrication, there's not a sensor to check oil level in the bearing. This is a pump version, but if you're used to our standard compressor, there's an optical oil sensor that goes in the middle of the end cap. That's not there for CO2. So you either have an oil pump, DP1, for protection, or you have to use some sort of oil float on the side for our 4 cylinders. Voltage is voltage specific, not because of the module itself, but because of the coils that are connected to the module. So if you have 120 volts coming in, we give you 120 volt coils so that they would work. Crankcase heater is included. So the crankcase heater connects back to that. So when we sell you the module, it'll have all these things pre-wired in there. So all you have to do is install the module on top of the terminal box, like it's shown here, pop the coils on, insert the oil heater, and then you have your wiring at the compressor done or finished. Number of unloaders, so you get 1, 2, or 3, depending on what you want to order. Obviously, we're showing 2 here on the 6-cylinder. And then the last designator is CO2, and that's because some of the accessories that are included with the CO2 are different than our for HFC compressors because of the pressure. So, and we'll go over what those differences are. This module right here is called an OLMIQ. It's not released in the US yet because it doesn't have UL, but looks a lot like the oil floats you're probably used to. The only difference with this one is designed to communicate with the CMRC. So it does the same thing. Oil here, oil float. Oil, if it gets low, it's a mechanical float, it's not optical. If it gets low, the CMRC interprets the low level and energizes the coil to allow oil to come back in and fill up. So it works pretty much the same. With that, you can use one without the CMRC that's connected. It just wouldn't communicate with the CMRC. So now when this comes out, you can install this, communicate with the CMRC, and it collects this data so that you can go look at the data and say, I'm filling up all the time. Maybe something's wrong. Maybe I got to investigate. It'll also kind of give you some more intelligent alarms based on the interaction of the oil float with the CMRC. So comes with a discharge temperature sensor, pre-wired, the mounting bolts, all that kind of stuff. But it is a kit, and it's going to have a bunch of wires hanging off of it. And the intention is to make it easier for people to install. Once you install it on the compressor, you have to bring power, obviously, and you have to bring a 0 to 10 volt signal to operate the unloaders. And that's all that's necessary. So that's really like 3-4 wires. And then if you do Modbus communication, you have to pull that in as well. That would be additional. So instead of running each of these wires back to the rack controller and to the relay board on a big panel, it's kind of compressor-centric. What does it do? So it's a monitoring device, so it watches, checks the motor overload. It replaces the little black SEB3 that's in the terminal box, monitors oil pressure, monitors discharge temperature, and then if you get the application kit, it includes 2 transducers, a high pressure, low pressure transducer, and you can monitor the suction and discharge pressure at the compressor. So this might be different values than what you have on your suction header and discharge header, because your suction header and discharge header, are however many equivalent length feet away from your compressor. This is giving us, all we want to do is make sure that we know what our compressor is doing so that we can help protect it longer and make it last longer, make it run more efficiently. We're not trying to control suction pressure at the rack. We're not going to turn the compressor on and off based on some value. And the only time we turn off the compressor with this module is a safety issue. When I say safety, either safety like high pressure or safety like the compressors on the outside of the application.
Can you change your low pressure and high pressure cutout, or is it predetermined?
You can, and I'll show you how to do that coming up. So this high pressure transducer does not replace the UL required mechanical high pressure switch. But it doesn't replace that because it's electronic and it doesn't qualify as a UL. But you can set one lower than your high pressure switch, mechanical high pressure switch. You can set it lower if there's a benefit to you to know that, hey, I'm way away from where I should be. I want to stop the compressor. So I'll explain that in a little bit. So based on the monitoring information, it becomes a protection device. Those values on the left are the same values we use right now, even if you're not using a CMRC. So the values haven't changed. 450 ohms on the 2 orange wires. The delta P is looking for more than 10 psi differential. And the discharge gas temperature sensor is going to trip somewhere around equivalent ohms of 300 degrees. A lot of people think that's high, but the difference is that we're measuring right at the compressor, and it's an insertion type sensor, so it's right in the discharge stream. It's not pipe, strapped onto the pipe 6 or 7 inches away from the discharge line. So that's why it's more higher than what you might think. A lot of times if people call in, we'll say 250 degrees on the discharge pipe because you're measuring on the pipe, not inside the compressor. But this is measuring inside the compressor, so we use that value. If you're doing application monitoring, the suction and discharge pressure will be recorded, and you'll actually have a little green dot in here showing you where you are in the application window, and I'll show you that a little bit later. But this is also being monitored to protect the compressor. So if you have this motor protection installed and activated, application limit protection installed and activated First of all, every startup, it waits 120 seconds before it does anything, because we know oftentimes you're out here and you need to pull down into the window. All right, so we ignore it for 120 seconds. The black line is the application window. So the inside yellow line here, that's a warning limit. So just giving you a warning that you are approaching the application limits of the compressor. It won't shut down the compressor. It won't do anything other than send an alarm out. And if you want to read the alarm, you can. If not, you can ignore it. That's what that orange line is. The yellow line. The black line, like I said, is the application limit. Once you go outside the application limits, we have another line right here, this peach color, I guess it is, the dotted line. So we'll let you run outside the application limits for 30 seconds. And during that 30 seconds, if you come back within the window, then it won't shut down the compressor. Those application limits, if you run outside there for a little while, you're not going to kill the compressor. Like anything else, there's always a safety factor that our engineers design in there, because obviously we can't have it. So as soon as you leave this pressure boundary or temperature boundary, there's a problem with the compressor. But you can't run there for long periods of time, so we give you 30 seconds before it goes back in. But on the screen, if you're looking at the CMRC, it's going to say critical limit. And that critical limit means I'm going to either reset if I go back within my application window, or I'm going to trip the compressor within 30 seconds if I don't. If you exceed the outside pink fault line that's dashed, the compressor trips immediately. So in temperature-wise, it's about 7 degrees outside of our application limit. So obviously that pressure is different for refrigerants, but it's a significant deviation from where we want the compressor to be, so that becomes an immediate fault.
So right now you're talking about the overloads?
No, this is...
Or are you talking about the pressure?
Pressure.
The
Transducer.
module?
Yeah, the two transducers, suction and discharge pressure, they're on a compressor, will be recorded, and our application window is in the software, and it changes per compressor and it changes per refrigerant, and it just makes sure that you're staying within the window. The question last class was, well, what happens if one of my transducers goes down? Do I have to shut down the compressor? No, you can go into the software and deactivate that function until you get a new transducer. So it won't be monitoring the application window anymore, but you don't have to wait for a new part to get it to work again. Many people use the CMRC without the application monitoring. Probably about half the people do. So it's a function that can be activated or deactivated depending on if you want to use it or if you need to deactivate it for troubleshooting purposes or anything like that. So your question about the high pressure and low pressure, so we have a way of, so I have the two red lines right now, they're outside the application limits, which means they would never come into play because the application limit boundary would stop the compressor first. But if you wanted to lower this high pressure cutout to somewhere in the middle of the application window, you could do that. Remembering though, that if you exceed that, it's going to shut down the compressor. But the compressor still has all the space that it could run safely, but you would shut it off on this height. So it's kind of like an artificial limit, but if you know your operating point should be down here, and you want to know when you're 2 times the pressure away from where it should be, and you want it to shut down, you can use those limits to do that. I'm not aware of many people who do, because for the most part, most applications want the compressor to run as long as possible. And you could probably get some other warnings from your main rack controller that you're so far away, but it is an option. It will also, so it's a monitoring protection device. It also does controls, and when I say controls, all we're trying to do is control functions on the compressor. Nothing to do with the system or the rack, just the compressor. Head fans, heaters, liquid injection, contactors, things like that. So in this case, if you're doing part winding, there's 2 outputs to control the contactors, so they're half a second apart, so now you can eliminate any external relays to do that half-second delay. It controls the crankcase heater, very simple logic, compressors on, heaters off, compressors off, heaters on. Simple to do with relays in the panel, but this takes care of it, so now you can eliminate that. So designers may be able to use less boards on their rack controller because this is controlling a lot of these little functions. I don't talk about head fans or liquid injection today because CO2 compressors don't need either, but it could control head fans and liquid injection. and it's based on a temperature. So typically head fans are on low temp all year round, right? Low temp's on even in the middle of winter because they're just on with the compressor off. With the CMRC for HFCs, we read the discharge temperature and only turn the head fan on when the discharge temperature exceeds 245 degrees. So it saves a little bit of energy, but if you have a ton of stores and a ton of low temp and have hands on all that adds up over, maybe at a higher level, at a corporate level. So there's no reason to run a head fan in the middle of winter, other than the logic is not set up to turn them off. It's just easier to run them that way. So last thing is the control of the CMRC, which is kind of what we're going to focus on coming up. And so again, we are not controlling the suction pressure. So we need to be told, and I say we, the module needs to be told what capacity level it's looking to run at. So your rack controller has a suction or temperature input that it's using for its set point, and it's going to send out a 0 to 10 signal to here, just like it would to like a VFD. So instead of going that 0 to 10 going to VFD, the 0 to 10 comes here, and based on that signal, and based on what you've set your minimum capacity regulation on, it will energize and de-energize the coil to meet that capacity demand. All right, so you can use 4 to 20 milliamps as well, but the idea is the same. It's just 0 to 10. If you are at 0, it's not turning off the compressor. You have to kill the run signal to this or tell this to turn off the compressor. 0 is minimum speed for VFDs and minimum capacity for various step. So keep that in mind. 0 is just minimum, not off. If you run at 0, the lower limit of 10%, again, it will never turn off, but what it will do after, depending on the refrigerant, but after between a minute and 2 minutes, it will de-energize one coil and load up the compressor to get some mass flow back over the motor to cool it down. But after 30 seconds, it goes back down to 0 mass flow. Again, we don't want to shut down the compressor, and if we don't get mass flow over the motor, it will shut down the motor temp eventually, so it will go through that cycle indefinitely until you increase the 0 to 10 signal, and then it will load back up. So you may see that if it's off long enough. If you're at 10% for that long, you probably want to look at the controls and change that because the compressor is not very efficient.
Can you do a 10 to 0 instead of a 0 to 10 for fail-safe?
Convert?
No. I don't think so. There's no. You can only switch to 4 to 20. There is an option, I believe, to set a minimum, a default capacity level if you lose the signal. But remember, if you lose the signal, it's going to. Well, no, that's not true. If you lose the signal, it's going to interpret it as 0. I'd have to check, but no, you can't flip-flop that to 0 to. You can't invert it. All right. If you do change the minimum, by the way, like this one's 10%, that one's 50%, you do change that slope, so your 0 to 10, the granulation between 0 to 10 will change, but that's all, the CMRC does that in conjunction with your rack controller. All right, so the last thing it does is the data logger. So it does save the alarms for 365 days with timestamps, so you can kind of review, are you getting the same alarms over and over again? It will record on-off cycles of the compressor, will record resets, alarm resets, or will record when somebody plugs into it. It's not login based, so it doesn't say who plugged into it, but you can see when it was last accessed.
Does this communicate with microthermal E2 downfrost, or do you have to physically go in there and plug into it to see what the alarms are?
If they've set up the Modbus communication, then it will communicate with those. If not, you'd have to plug into it or use Bluetooth.
But if not, it'll just send out like a dry contact alarm to notify the.
Yes, so there is alarm output. So if it's not monitoring Modbus, there's alarm output that would say, I don't know how they label it on there, but it might say compressor 1, CMR.
Fault, yeah. And you go there and hook up your phone and see what it actually is.
Yes. Many people are using the Modbus so that you can get all the data that it's outputting onto a screen. It just depends on.
You have to have a laptop, or can anybody go there with their phone? Or?
You can do phone, and I'll talk about that in a little bit. The phone works the same, except the interface is obviously much smaller and might not be as easy to use if you really have to do some digging into the data, but you could. Last thing it does is it does collect all the other data, pressures, temperatures that it's recording. 10 seconds while the compressor's on, 60 seconds while the compressor's off, and based on how long the compressor, it's only 1 to 3 weeks. But if you're recording via Modbus, you can save all that data for eternity on a bigger hard drive somewhere. So that all depends on end user, spec, and that kind of stuff. But it is 1 to 3 weeks depending on how often the compressor is running. So this is our 8-cylinder CO2 compressor. You will probably never see one in a supermarket. It's just way too big for a supermarket. So this compressor actually is 3.5 times larger than our largest 6-cylinder compressor at the moment. The reason I have it up here is to kind of show all the features of the CMRC because it's the best picture I have. So there's an unloader. Here's a discharge gas temperature sensor. Here's the Delta P1 for positive displacement oil pump. Here's the high pressure transducer. Here's the low pressure transducer. 2 more unloader heads. There's the module, and that's the oil MIQ. So
we can't use that oil control here in the States?
Not yet. We're working on getting UL for it, and then once we get UL, then you can use it. And so the only difference between this and our 4 and 6-cylinder is because of the size of this compressor, we have a separate mounting location because we could put a plate there to mount it to. Our smaller compressors, there's no physical surface area to mount it, so we mount it on a terminal box. So you will not see it mounted on the side like this on the compressors you're working on. So last class, somebody asked about how do I check the oil pressure. So it's the same oil pressure differential across the oil pump. Let me rephrase that. So it's the same as a standard compressor. So if there is an oil pump on the CO2 compressor, the 6 and 8 cylinders like this one, you're going to have 2 Schraders, right? There's one and there's the other. So that's the high, this is the low. You put gauges on there and you can see the pressure differential going across the pump. The pressure differential for CO2 compressors is the same as HFC, so a new compressor should be somewhere between 20 and 50, and it will trip at 10. The pressures at those 2 points are going to be different, right? It's going to be 600 and 1500, but the differential, maybe the differential of the pump, because all the pump is doing is going from suction pressure to 50 pounds above that suction pressure. It doesn't need to pump it all the way up to 2,000 PSI. It just needs to pump it up, lift that differential enough to get oil to flow through the compressor. So the absolute values are going to be much higher, but the differential is the same for HFC or CO2. So a couple things to make sure you're aware of. First, with the CMRC, with the vari-step unloader head on a CO2 compressor, there's this extra port. They're up there in the right corner where it says question mark. That port is not for service or anything to do with operation. It's strictly a manufacturing requirement. Because that check valve's in the valve plate, when we burst test these and leak test these, if we don't get access to the one side of the cylinder head, when we fill up the compressor with pressure to check for leaks, that check valve prevents gas from going into that side of the head, and therefore we wouldn't actually be checking to see if there's any issues with the either casting or leaks. So they actually put a fitting on there so they can pressurize both sides to the same PSI and then check for leaks, and then they put a plug in there. So that's what that's for. Shouldn't be used for service or operation. The way we leak check these, by the way, or burst test them, I should say, is because of the high pressures required, we got to exceed the 2,300 pounds for the burst test. It's like 1.5 times the pressure for a certain amount of time. We've actually put it in a tank of water. The tank has steel like 2 inches thick, and put it in a tank of water because if it does burst, we need that water to absorb all that energy. Since I've been in BITZER, not CO2 but HFC versions, we've burst 2 compressors. Both end up being fissures and small cracks in the castings, and I mean it shakes the whole building, and it's loud. But the HFC we put in a barrel, it almost looks like a wine barrel. It's wood with big steel doors, and they close that off. and the wood, is designed to absorb any of the impact. But for CO2, because it's even higher pressures, we do it in a dunk tank. So that's what that one's for up there. So the other thing I want to point out is that there are differences between the CO2 unloaders, as I mentioned before already, and the CO2 CMRC. So first of all, if you're used to our HFC compressors, our unloaders are football-shaped with two bolts. These unloaders are D-shaped with 3 bolts. So again, we have to hold in more pressure. They're Parker stems instead of Danfoss, so the coils are different. Not a big deal because you'll get the right coil, but I just want to point that out. The discharge gas temperature sensor is a different one. It has to hold this 2,000 pounds, so it's a different discharge gas temperature sensor. And then the application monitoring transducers are also different. Again, has to hold in this higher pressure, so number one, and also has to be able to read 2,300 pounds versus 500 pounds of a standard high-side transducer on our standard compressor. So the components of the kit, of the CMR kit, most of them are not interchangeable, but the module, the actual module is. Let's see here. I'll show you the module. But this actual physical module is identical. You would just pick the different refrigerants and different parameters for the different compressors. All right, connection. So we have 2 ways to connect. One way is by downloading the app on your phone or downloading the software to your PC and using Bluetooth. So I'm going to connect Bluetooth from my PC so you guys can see it up on the screen. But you can connect. You can do everything from the phone that you can do from the PC. It's just the interface is much smaller. So my recommendation is if you use the phone, if you happen to be at the store addressing something else and you just want to quickly take a look, you don't seem to see any alarms on the controller or anything like that. You just want to take a look. You can tie in, kind of look at it quickly, make sure everything's good. If there is an alarm on the rack controller, you can tie in real quick and see what it is, and maybe it's something you can reset from your phone because you know it's associated to the reason you were called in to begin with, and you can reset it from your phone and be done. But if you have to do any real diagnosis or real changing of parameters or interpretation of graphs, it's kind of small to do it on this.
Bluetooth signal always on, or you have to hit like the button and stuff?
Bluetooth signal is always on unless you go into parameters and disable it. So you can't turn it on and off from a button on here, but you can turn it on and off if you connect to it. You can only turn it off, disable it if you connect to it hardwire though, so that you can't walk into a rack room, log in on Bluetooth on your phone and change the default password and leave, and then the next guy who comes. But if you're tied into it, it does let you do that. I guess Bitzer's philosophy is that if you're allowed to get that close and plug into something, then you're allowed to change those parameters. I guess that's the deal. So the default password is 8670. I'm not giving away any top secret information. It's actually in our literature. But if 8670 doesn't work, that means somebody changed it to something else. And
Is there a way to contact you to
reset it?
Yeah, you guys have a default password?
No. So we have a little Apple-ish. You can't call us and we can't reset it. But you can go in with a hardwire and always connect. So hardwire, there's no password. All right, same thing. If you got that close, we assume that you're allowed to. So then you can go in there and enable and disable the Bluetooth and reset passwords, stuff like that. The other option is this best tool or best converter. So that consists of the converter, which is the square box, and then this cable to connect to your computer. And we have multiple cables to connect to devices because we have multiple different devices, and for whatever reason, they have different connections. I'm not an electrical engineer, but I would think they would be able to come up with one connection for everything, but they haven't. So if you're going to connect hardwire, you pull this little plug here in the top right corner, find the correct adapter piece, plug it in, and log in, connect via your computer. That corner, that location is also the location of Modbus, so there is Modbus. You'd probably have 4 wires coming out of that Phoenix connector. You either have to connect via Bluetooth or disconnect the Modbus to connect your tool, one of the two options. If you disconnect your Modbus, you're probably going to get some errors on your controller somewhere about communication errors, so just kind of remember that. So this is the device. It looks the same, like I said, as a CO2 versus not CO2, same shaped box, same connectors. You have to tie into it to program for CO2 or not. Next few screens are, because I think they're going to either save these as PDFs or recorded. These we're going to look into more in depth when I plug in, but if you have to go back and review, these are the main screens that you want to kind of focus on. So overview is exactly it. When you log in, this is the first thing you see. It just gives you the status of the compressor. So you see discharge 300 pounds, suction 380 pounds, discharge 940, temperatures, load requirements, discharge temperature. If you had transducers on it, you'd have a window here, and I'll show you that when I plug in, an application window, and a little green dot to show you where it is. And then on the left-hand side there is just some static information, serial numbers, names. All right, so if you have multiple CMRCs, you want to make sure you name them so it's easy to identify which one you're plugging into. If not, it gives you some random number, and you'd have to guess and check to see what it is. But you can put in store name, location. You can put rack 1, compressor 1, rack 2. So it's all free form, but you want to put something in there. I'll show you how to do that if it's not already there. Monitoring, so this is where you get the graph data. This is what I'm talking about. It's kind of harder to evaluate any of this on the phone, but you plug in. Down here has to do with actual compressor operation, on, off of the coils, the heaters. Up top, it has to do with all the data it's collecting, pressures and temperatures. So when the compressor shuts down, so the black line is the actual capacity that's trying to maintain, so that means the compressor's on. When the black line goes down here, it means the compressor's off, obviously 0. So what happens here is you can see that when the compressor shuts off, the blue line is your suction pressure / temperature. It goes up, obviously. On a rack system, it might not go up so dramatically because you have other compressors running, but the discharge pressure goes down and your discharge temperature goes down. All makes sense. When the compressor turns on, we have our suction pressure start to come down, our discharge pressure start to go up, and our discharge temperature start to go up, which all makes sense. So one question I have for you, if when you start the compressor, your suction pressure goes down, your discharge pressure goes up, and your discharge temperature goes down, what problem do you have? If your discharge temperature goes down when you start the compressor, what problem might you have?
Phase rotation.
It doesn't matter with recips. It doesn't matter for screws and scrolls. If you're running backwards, you'll create more friction and heat.
Your temperature sensor goes down when you turn it on? Is that what you're saying?
Yes, your discharge temperature goes down when you turn on the compressor.
Your loader step?
No, not necessarily. No, everything working fine it's been off for a long time. I'll give you a hint, your crankcase heater's not working. What might be in the refrigerant, or what might be in the oil?
Liquid.
Liquid. So if you have liquid in the oil in the crankcase, when you turn on that compressor, all that liquid's going to get sucked up through the oil pump, and it's going to depress, it's going to vaporize and depress the discharge temperature. Because the motor heats up, and that's where the motor works the most. It has to overcome almost lock rotor amps to get that starting friction, overcome the starting friction. So you should have a lot of heat going into the compressor, and a little bit of mass flow starting to come over the motor. But if it goes down immediately, it means it's evaporating all that refrigerant that might be in the oil, and it's going to depress. So it might not go down, but it might stay flat. But it should have, so that's how you can use this for troubleshooting. It should have almost an immediate increase. Now, it might not be super steep, but it should be going up and not down
all
or
this
flat.
information, you guys should integrate amps and NOV.
Amps is something I think will come up in the next version. We actually have three slots, L1, L2, and 3. They're not active here, but that would be that's something we're kind of working on.
How is the actual compressor load interplanted?
So that 0 to 10 signal. So the rack controller says I need 50%, and let's say, for argument's sake, 50% is 5 volts. So when 5 volts come to here, the algorithm, depending on how many unloaders you have selected, the algorithm will energize and de-energize the coils to get 50% mass flow. but that's a it's a theoretical calculation based on the operating conditions and the refrigerant, and it knows the displacement and the mass, the mass flow at 100%, and then it will energize and de-energize the unloader coils to get the 50% of that.
Now, are a lot of OEMs using this, or is it something we have to do after?
No, there are a lot of OEMs using it, not for CO2 yet, because this is only available with the TE models that just came out last year. So, you probably haven't seen any for CO2 in the field yet, because it takes a year to year and a half by the time somebody actually orders a compressor until it gets to commissioning because of construction and all that stuff. So, but for HFCs, there are a lot. There's some food chain out east, Food City, they have it on all their racks. Not necessarily all their compressors on every rack, by the way, but for sure anything that has unloading, they're using it. And there's several other chains that use it. I don't know of any. I know of onesie, twosie special jobs that have put CMRCs on every single compressor for monitoring purposes, let's say, more so for functionality. One thing we're going to working on is the next version of this is going to be modular. So right now, you buy this, and this is like a Ferrari, and if you're only driving through the village, you're not really having fun with your Ferrari, but you have to get all the bells and whistles. The next version is going to be modular and programmable. So the basic version will have, let's say, 4 outputs, and you can say whether it's fans, injection, or unloading. And then if you need all that stuff plus more, then you get an extension module that has more outputs, and you can do everything. So that would make it more advantageous for putting on more compressors because you're not paying for all these features you can't use. A lot of industrial type jobs where money's less of an issue, they put it on every compressor for the data logging and monitoring. But for supermarkets, for the most part, like little tighter budgets, they're going to use it more for functionality than the other parts. Down here, these are the alarms. So they correlate with the colors of the type of fault. So a warning's yellow, a critical alarm, which means I'm going to turn off soon if I don't get fixed, is orangish. This is a little more yellow, but I don't have any faults up here. And then red means it's off, it's a fault. And you could toggle all these things on and off so you can put more or less information on the chart to really dig down into it. And the oil heater, I'll show you that in a little bit. So you also have these 2 slider bars so you can get more granular with your data. If you spread this all out, you lose a lot of the detail, but you'll see a nice flat line. If you crunch it in, you'll see a little more definition and kind of do a little more troubleshooting. Configuration, this is where you're going to go to adjust any parameters. So let's say you have application monitoring and one of the transducers has gone bad, or you think one of the transducers has gone bad, and you need this equipment to run. You would come down here, and I'll show you where it is, and you would change it from yes. You put no in this column, and then you transfer it, and it'll cut off that functionality, and the compressor will ignore the inputs and run. Application monitoring is an option to begin with, so it's not required. So you cannot deactivate any safety that is required, though. So that's one thing you won't be able to do. But I'll show you how to manipulate the software to get stuff transferred in. This is also where you would put the name of your equipment, customer name, system location, Bluetooth name. This is where you do that to input it into the software or the program. This card is a plastic card with a metal ring, so hopefully it ends up getting to the job site. It's just a quick reminder and a cheat sheet, quick start guide to make sure that you will understand if you need to add something to the actual settings, how to do that. OEMs should be doing this because if it gets to you without programming, it will not turn on. You'll try to turn it on and it won't do anything because it doesn't know the compressor model, doesn't know the refrigerant, doesn't know whether you have unloaders or head fans or anything else, so it won't do anything. So if you plug in and the middle column is all either blank or defaults, then you'd have to go through and do the programming, which is not hard. There are not too many parameters, but this is how you do that. Top bar, you have 3 important buttons or window or icons, the new, the connect, disconnect, and the transfer, and I'll show you how to use those. And then this is kind of silly but important. The only place you'll know if you're connected or not connected is down here in this bottom left corner. So if you have a small screen, if there's a lot of glare, it doesn't pop up and say you've been disconnected. Like if you're using Bluetooth and you happen to walk away and you got disconnected, there's not going to be a big sign that says you're disconnected. All that happens is this goes from green to red. And I'm telling you this because when we first got this, we've been playing with this for 5-6 years now, but when we first played with it in our lab and we had it on our phone, we'd walk away, we'd come back, and we'd try to fiddle with things, and nothing was working, and it's because it was red and we weren't paying attention. So just keep that in mind. If you think something odd's happening, go there and make sure you're connected. This will tell you what version you're in, and if there is a new version right here, it'll say updated version available. You do not need to spend time at the job site to update versions. Most of the time, that updated version is going to have new functionality that doesn't exist on your compressor anyways, so it's not a big deal. I do recommend that you keep it up to date as much as possible, but if you're in a pinch and in a hurry and you hit this update, it's going to take however long to do, and you're sitting there twiddling your thumbs while you could be doing work. So keep it updated, but it's not something you have to do if you have other critical things to do right away. This is another way you can quick interpretation. You won't be able to see it maybe, I don't know, but here, there's one on the back as well. We have a sight glass on the outside of the box so you can see into this without opening the box. But if you walk by and you see something flashing red, just like everywhere else's equipment, red is bad, green is good, yellow is okay. Blue just means somebody's connected, either hardwire or Bluetooth. So that's what those 4 things mean. So if you see red, then you definitely want to bring out your phone, see what the red is causing, and then maybe you want to connect with your computer if it's a bigger deal. Alarms, this will log your alarms, and I'll show you some more alarms later on, but this one says minimum compressor runtime not respected, which means when you turn it on, you turn it off before 5 minutes. We want the compressor to run at least 5 minutes because, as I explained earlier, the motor works the hardest when it first starts, draws a lot of amperage, gets hot, and if you shut it down before you get enough mass flow going over the motor from the suction, then it'll stay hot, and if you start it up again, you're gonna short cycle and burn the motor. So it's not a fault, it's a warning. You can do that until you kill the motor, kind of, because again, we are not, if you have something very important you're trying to keep cold, we don't want to get in the way of that happening. We're just telling you that that's not good practice. If it's a safety issue with a compressor or a real protection module, like it exceeds the motor amps and it's going to burn the motor or like cause electrical fire, we have to shut it down, and we will.
Does this or will it ever monitor input voltage for phase loss?
It may. Again, we have the option right now. It doesn't have that functionality, and I'm not 100% sure it's going to have that functionality in the next version. But, what's that?
The rack should have that.
The rack should have it. Plus, there's it all comes down to we have to evaluate cost. So it'd be great to have all these features, but then nobody wants to pay for all it. Everybody wants it, but nobody wants to pay for it kind of deal. So I can't promise it. It is in the thought process because we have locations to land that if that functionality is included. And with this modular way of doing it, it might be something that comes sooner than later because then you can kind of pay for what you want versus everybody has to pay for something that they don't use. Documentation is exactly that. This is where you can go to and find all the information, most of the information related to CMRC. So it's always there. It lists all the alarms possible so that if you have certain alarms and they went away and you wanted to look at it later, you can come in here. And this is the alarm code. This is the brief description. The little question mark is information. So if you want to see the troubleshooting tips or what might cause this alarm, you can click on that. A window opens that says check your sensor, check your wiring, check connection CN7 on the board. It'll direct you right to where to check with your meter, that kind of stuff. This column here tells you the type of reset. So a restart means you got to kill power through the module. Just like our SEB module, if it trips, you have to shut power off. You have a reset button, hopefully. If not, you have to disconnect it for 5 seconds. That's what this one means. Timed resets, if you have it enabled, which is in default, if that parameter falls back within the application limits, it will allow the compressor to restart if it gets a call to restart. So your discharge temperature trips at 302, compressor's been off for a few hours, the temperature has gone down to 100, compressor's been called, to run. A timed reset will allow that compressor to run. The default delay is 60 seconds. And then an external reset at the top, that one requires a connection, either Bluetooth, Modbus, or hardwire, and you just hit reset button on the screen and it will reset it. But it still requires somebody to acknowledge that alarm and reset that alarm. All right, so I am going to hook into this module right now, and in the meantime, if anybody has any questions, they can ask, and I'll see if I can do two things at once. Is anybody connected to this, by the way?
Yes, that was my question. How many people can connect to that?
One.
Okay, so he's got to disconnect.
Yeah, so the reason I ask is I can see this blue light blinking. In the first session on Tuesday, when I went to do this, I'm clicking and, all up here thinking I'm got it going on, and it wouldn't connect. I'm like, uh-oh. And then somebody said,
I disconnected.
okay.
How far can you stay connected to these devices?
What's that?
How far can you be connected?
Whatever the standard Bluetooth is it 10 meters, 30 feet, something like that? So now I still have a fault blinking, but I have the blue light off, so now I know it's disconnected. So the icon is the little, I'll click on it. Hold on, I gotta get rid of this. All right, so I have the icon over here. It's the BITZER B with a wrench. So that is the icon for the software. You can download the software from the App Store. It's called BITZER Electronic Service Tool. That's what BEST stands for, B-E-S-T. Or you have to go to the BITZER website. If you type in BEST software download for Windows, it should pop up, direct you to the website to download onto your computer. So I opened it up. All it's done now is open the program. You're still not connected to anything. So the first thing you have to do, and that's what's on the little red card, is you got to go up to this new. Now I'll blow this up here. You got to go up to this new button. You click on that button and it lists all the different IQ modules or connection possibilities. Okay, the top two are integrated inverter compressors, one with a recip, one with screws. The next one is our external Varipack, so you see the Vari brand name on there. That's an external inverter. We don't sell those here in the United States. EchoLight and EchoStar are condensing units. In the US, we only sell the EchoStar. And then the last three are actually physical compressor modules. CMRC for recips, CMSW for screws, large screws, by the way, and then SEI1 is for smaller screw compressors. So you click on here. You can't double click, which is annoying, but you can't double click. You click on it, hit OK. What's that?
I just thought it was funny.
Oh, yeah, like I said, from working on it over the years, little things you wonder why they didn't do, but so now you're still not connected. You're just prepared this to look for a CMRC. So if you click on a EchoStar and you connect to the CMRC, when you get to this screen and you try to connect, it's going to give you an error because it's looking for something to communicate. It's looking for an EchoStar and it's in the wrong screen. So that's why on that little card that comes with it, we also highlighted the connect button, which is this one right here. So at this point, I'm preparing, you can see up there in the top left, it says IQ module CMRC01. That's what it's looking for. I go to connect. I'm going to do the Bluetooth because I actually forgot my tool, so Bluetooth. And it's going to look for devices in the area, BITZER devices. And this one we already have labeled, but if you don't have it labeled, like I said, it's going to come up with, let's see if it pops up. It's going to come up with a random, not random to me, but just some numbers and letters. And it's very difficult if you have more than one to associate which number and letter goes with which thing. So you should go in and label it. Like hit here, first thing it's going to do is ask me for the default 8670. Like I said before, if you connect hardwire, it skips this step. It goes right to the next screen. So if it should be about that fast. Other equipment might take a little longer, but it's going to have that green bar for a while, and then it should reset and kind of the green bar should move. If you stick to that green bar for too long and nothing's doing, then I would disconnect and try to reconnect. So I'm on the West Coast versus East Coast, so it's telling me the time zones are screwed up. But so this is the overview screen. I'm connected to this. You can see is Bluetooth, so I am connected to this. This is a little green dot that I was talking about. So the suction transducer and discharge transducer on the compressor. Up there we showed in temperature because we're taking the pressure, converting it using the PT chart and showing the temperature. And so, but it's really reading the pressure. So if you pick the wrong refrigerant, and I'll show you that later, it's going to be in the wrong spot because it's only as smart as what you tell it to do. So you have to make sure you have the right refrigerant. If you're not doing application monitoring or you don't have transducers, that doesn't exist because it can't do the math. It can't convert the pressures to temperatures. In real life, this little green dot's going to move around because we're never so stable. And what it does is the dark green dot is where you are, and the other lighter green dots is where you were, and they basically fade away, kind of like an etch-a-sketch eventually. So hopefully your operation is pretty close, precise, and not all over the place, but it depends on your application, I suppose. So over here, it just has, again, some static information, serial numbers, model numbers, how often I've turned on and off the compressor, how often I've turned on and off the module, how long it's been in operation. None of these things you can change. They're all just static. Nothing on here you can change. I forgot you can zoom in on this by double-clicking, but that's all you can do. Monitoring, this is kind of where you get a lot of information, especially for troubleshooting. So under the monitoring tab at the top, it is alphanumeric, so you have all of this data. So it's in fault, the relays are off because the compressor's off. It's still getting a signal that needs 68%, but it can't do anything, so it's 0. So you can go through here and see with the information. The diagnostic one is very helpful for troubleshooting because it actually gives you see over there it says CN9, CN7, CN6. So that's the location on the board where if you want to check with a multimeter, am I reading 5.9 at CN13? It's telling me I am. I can go there, read that, and then I can go back to my rack controller and read what the rack controller is outputting. And it should be something close. If the rack controller is outputting some value, and at the other end of the wire it's a different value, then obviously there's an issue there. It's telling you that the unloaders are all off because the compressor's off. So there is a slight delay because obviously the unloader energizes and the screen has to update. But in a minute when I reset this, you'll see that those go from on to off as they energize and de-energize. So you can use this for troubleshooting to make sure the relay is closing. Even though this says it's closing, or the screen says it's closing, if it's not closing here because it's fried internally, then you can check that. It should be closed, and I'm measuring it's not closed, something's wrong. The operational graph is, this one is called the live log. So as soon as you plug in, it starts recording data. It records data when you're not plugged in, but when you plug in, it starts recording data, and you can save what your time that you're plugged in just if you want to as a live log, or you can save the whole data log, the 1 to 3 weeks worth as well, and I'll show you how to do that in a minute. So I'm going to go to the alarm screen. So I have these faults. So too many time resets in 1 hour, too many identical time resets in 24 hours. So I told you earlier that we don't shut down for like some faults, but if that fault happens, the same fault happens 5 times in 1 hour, we will shut down. Because the time reset after 60 seconds, when it comes back into the window, it's going to let you start. And we don't want to do that over the course of a whole day. If your motor is heating up for some reason and within a minute each time, then somebody has to come take a look at it. So they can turn into lockouts, but if it only happens once, then it's not going to do that. But these two are both external, so if you can see the reset type, external. So all I have to do is go to this reset button, hit reset, and it's going to clear all those. And now I have a high pressure alarm. So on here, this is my switch here. It's saying the main high pressure switch is been tripped, and I forgot to set this way. So it's a timed reset, but I'm going to reset it here because I don't want to wait 60 seconds and waste your time. So I can reset it here, and now I have no faults. So now I can actually start the compressor back up, and I'm going to go to your monitoring screen. I'm going to start the compressor over here, and you should hear there are 2 clicks because I have set it part winding, so they're half a second apart. So that closes the relays, energizes, get to the coil on the contactor so they can energize. And then Down here, you can see that now I am doing supposedly some work, even though it's not really doing anything. But here are your faults. This was your high pressure, I bet. This one is going to be too many timed resets because I didn't wait that 60 seconds. All right, so if I scroll over here, I can highlight it and it tells you what the fault is. If I come over here, it tells me, oh, low oil level. Oops, better fix that, or else it's going to trip. And I'll do that in a second. But what it does is it turns on the compressor, right? And then it's trying to maintain this suction pressure. So here, this gray line is actual activated capacity. So the gray line means that one of the two is energized. If you have two unloader heads, one of the two is energized to get to 50%. And then the 100% means they're both deactivated. Because remember, you energize to unload. So it's energized and de-energizing between 50 and 100% to get this 68% that it's shooting for. If I click over here, all right, so I click this, and what it's basically telling me is that when the compressor's off, the oil heater's on. So again, this can be used for troubleshooting. You can go to the location of the oil heater on here, make sure there's voltage there. And then if there is, then your oil heater, if your oil heater's not hot, or your case is not warm, then your oil heater's bad. And it's not the module. You change the oil heater, you're good to go. If there was additional cooling and I had a head fan, I could pull here and it would add it on here, but there's no cooling, so it doesn't show up. Here is your temperatures. Again, we only have resistors in there, so that's why they're so flat. But you can use this to do to evaluate your system. Obviously, these things are going to move around. You have scaling on both sides, right, to drill in or zoom out. The things labeled on this side are on this axis. The ones labeled on the other side are on the other axis. So you have two different axes. So here is the suction pressure, and that's not negative, by the way. Obviously, it looks like it's negative 8.9, but it's and the discharge pressure. Oops. So this is 94, not 88, right? Anything on these would be read with this scale. Anything on this side would be read with this scale. Going to configuration. So this is where you would go to change the parameters of the software. So I have the wrong refrigerant, so let me change that to 449. The reason I'm changing to 449 is because I know where it goes and I won't get locked out. This isn't NASRC, this is NASRC Southern Cal. All right. I don't want 25%, I want 10% minimum speed, not speed, capacity. If you enter something that's out of bounds, it's going to turn red. And it won't work. It's not going to work. If you try to transfer, it's going to give you an error about transferring something that doesn't exist. So that's what red means. Sometimes you'll see a red in the model number, because if you select CO2 and select a non-CO2 compressor, it's going to tell you those two things aren't compatible. There are several that are drop-down, and obviously you can't screw up a drop-down. If you put it, the only thing you can screw up is if you don't have the VFD and you select VFD, but it will let you transfer all those things in drop-downs. So I'm going to say 10%. If you go down here, this is where you can enable or disable Bluetooth. I won't be able to disable it. I shouldn't be able to disable it because I'm hardwired, but I'm not going to do that now because if I disable it, I won't be able to connect it anyways. But this is where you would change the Bluetooth name. So at the top, you do location, you do whatever you want to nickname the module, R1, C1, Rack 1, Rack A, C2. Here's where you put the nickname so that when you pull it up on Bluetooth, you know which one you're talking about. All right, and you can either do the same thing, Rack 1, Rack compressor 1, Rack 2, compressor 2, medium temp, whatever you want to do. Modbus I would not touch. This has to do with Modbus programming. The programmers would change the address. That's probably the most important thing. If you change the address, then it would no longer communicate because one end is looking for 48 and you've changed it to 47 and they won't match. Here's where you can enable or disable the timed reset, and then you can also change the length of time. So if you want it to be more than a minute, 2 minutes, 3 minutes, you can do that. If you want every fault to have to be addressed either remotely via Modbus or the app, or then you can disable it completely. So if I go up here to transfer, you have 3 options. User settings to device, so anything you put in this column to the active setting, which would mean basically putting it from the computer to the device. That's typically what you're going to use. The default settings would go from this column to the device. I wouldn't use that because the default settings are not set up for compressor specific. They're just the default from the factory, from the OEM who builds this for us. And you'd have to redo everything if you did that. The last one can be used if you're tinkering and you want to save where you were before you tinker so that you can get back to it if your tinkering makes it worse. You do this copy actual settings to user settings. It copies this to this column. Then you save that file, and you'll have a record of where it was as a baseline. And if you really screw things up, you can open that file up. You have all the parameters. You connect to your device, and then you transfer user settings to the device, and you've got it back to the original settings that were shipped with it. So, a couple things. Either you're not connected, the compressor's on, or you have a red indicator, it won't let you transfer. You can't change refrigerants during mid-operation, right? So it's just some things you have to keep in mind. So I had the compressor on, so I'm going to turn it off, and as soon as I turn it off, now it's going to let me transfer. I hit OK, and you can see in the background that these things will change in the green column. While it does that, all right.
You have to run its own independent power?
Yeah, so it does need a minimum of 3 wires connected to it. Power and 0 to 10 if you're using control of the CMRC. If you're doing Modbus, then there's a whole another set of Modbus wires. But so the
24 volts, or what's the power supply?
120 or 230.
Oh, nice.
Internally, it has 24 volts and controls a lot of the functionality with 24 volts, but we're bring 120 or 230. So you see everything transferred. You're good. It does leave what you had in the user column, so you can double check everything transferred. I'm going to go back to this monitoring, and I want you to notice. This. So remember, with 134A, this dot was up here because of the PT chart for 134A says that pressure equals this temperature. For 449, that's way down here. So we're outside the limit. We're inside the limit, but outside the warning range. So when I turn on the compressor stopped right now. We're not going to have any alarms. I'm going to clear this. We're not going to have any alarms set up. By the way, did you notice it was gray before I hit it? Gray means it's been cleared. If it's still active, it's going to be red, yellow, or orange. But if it's gray, it's there for, it's a timed reset, it's cleared, and when you hit reset, then it will disappear. But because the compressor's off, it's not registering any application limit faults. When I turn the compressor on, I should have turned it on earlier. Remember, it ignores the fault for 120 seconds, but eventually, because it's operating just outside of the yellow line, eventually it's going to come up with an error that says, I'll leave it there. The error is this one right here. 3002 envelope low no, actually it's going to say low condensing, I think. This one right here. Because the bottom line of this application window, these are your condensing limits, low and high. These are your suction limits, low and high. This has to do with pressure ratio, and that one has to do with discharge gas temperature, so that's why they're cut off. But because we're down there, after 120 seconds, it's going to give us a fault. Now notice also that the percentages changed from 68 to 62, again, because we changed refrigerant, and it's doing everything based on refrigerant. It's not doing anything like, in the algorithm, it's based on refrigerant, not based on what BITZER says it should do. Still hasn't changed, so apologize for that. But let me, while that's doing that, I'm going to open up a file of a CO2 compressor just so you can see some real CO2 data. And I got 3 minutes, and I apologize for the end. I will be around for questions if you have any. So this is a CO2 compressor. You can see the pressures, right? It's a MTE cylinder, transcritical. There's some pressures and temperatures. So what I did is in the other view, you go here and you go to this data download, and you can save the data to download. And then I have it on my desktop, and then I go to open, or I double-clicked it and I open it. To save it, you download it first. You would go here and download it first on a data log here. Live log is while you're connected. And then you go to save to PC, and it will save the file to your PC. And then you can open it directly from your PC like I did here, or you can go to this open button and find it on your PC and open it. But what I wanted to show is so when I go to the monitoring, it's not showing me anything yet. You have the file, but you have to go here and collect. So this has been saved 3 different times. You have to click on the one you want. And then when you click on the one you want, it will open it up and then populate the graph. I hope. All right, so now we have all the data that was during that connection period that you saved from the last time. So first thing I'm going to do is come here and kind of get it closer so I can actually read something. So this is oil level fault. This is oil low fault, so it didn't correct itself, you shut down. This has 2 sets of unloaders, so when the capacity is required above 50%, it's energizing 1 unloader at a time, and it alternates to keep cycle rates at the same. And then when I need below 50%, it energizes 1 coil all the time, and then energizes the other one intermittently to get below 50%. All right, so that's what these gray lines are. The black line is actual. No faults on here, which is a good thing. I mean, not very many. It's a good thing, but you can see the temperatures and pressures, same thing. When the compressor shuts down, pressure goes up, discharge pressure goes down, discharge temperature goes down. And then go back here. There we go. So after 120 seconds, I get this warning, and this warning, go back to this, is because I'm outside that yellow line. At startup, though, the delays are 120 seconds. So one last thing I wanted to show. I got to go back to this one. I think So if I go here, it gives me the troubleshooting information. So not only does it say stuff like check your oil pressure, but it will also, in some cases, if it's related to the board, it will tell you where to go. Check the wiring according to technical information 230. Brown wire OLC must be connected to CN9, terminal 1, and CN9, terminal 2. So directly right to where on the board you can go to troubleshoot to make sure the board's doing its thing. Not every information box has that, because not every information box is directly related to something on the board. But we do try to give you as much information of troubleshooting, not because we don't want you to call us, only because if you're there and you can solve the problem yourself a lot faster, it's good for everybody. So I'm going to put up the barcode thing, QR code. I apologize. And then after that, I'll put up the contact information. If you want to snap a picture of that. We'll do that, or vice versa. I guess I don't know which one's first. It doesn't matter, but we only have a few people, so contact information first. Go there.